So you're welcome to the last topic for this particular course. And under this topic, under the study session, we'll be discussing electrochemistry. We'll be discussing electrochemistry. Electrochemistry is the branch of chemistry that deals with the transformation of electrical energy to chemical energy and vice versa. So that means that we can convert energy from electrical energy to chemical energy, or from chemical energy to electrical energy. Electrochemistry deals with the relationship between electrical chemical phenomena and the laws of interaction of these phenomena. Under electrochemistry, there are two processes in which both are interrelated. We have electrolysis. Electrolysis is one of the processes, and it is the process whereby electrical energy causes chemical changes, and these reactions take place in an electrolytic cell. That means that in an electrolytic cell, electrical energy causes chemical change, and this process is called what? Electrolysis. Now, the other process is what we call redox reaction, that is oxidation reduction reaction, and this takes place in a device that is called electrochemical cell. Remember, I mentioned electrolysis takes place in an electrolytic cell, whereas redox reaction takes place in an electrochemical cell. Now, what is an electrochemical cell? Electrochemical cell is a device that is capable of either generating electrical energy from chemical reactions or facilitating chemical reactions through the introduction of electrical energy. An example of electrochemical cell is a standard 1.5 volt battery, normal battery that we use for our wall clock and other devices in the home. An electrochemical cell consists of two half cells. Each half cell is made up of an electrode and an electrolyte. We will understand better when we get to the slide of an electrochemical cell. Now look at this slide. This is a simple setup of an electrochemical cell. If we notice, we have the anode side and we have the cathode side. We also, in the anode side, we have the zinc sulfate. That zinc sulfate is what we call an electrolyte. Also, we have at the cathode side, we have the copper sulfate. The copper sulfate is also the electrolyte. The copper sulfate is also the electrolyte. We have zinc metal at the anode side, and we have copper metal at the cathode side. Now, on the anode side, oxidation reaction takes place. Oxidation reaction takes place at the anode side, while reduction reaction takes place at the cathode side. Now, if you notice, there is what we call a salt bridge. A salt bridge. This salt bridge helps ions migrate from this electrolyte, from zinc sulfate electrolyte to copper sulfate electrolyte. So this salt bridge is for the migration of ions from one electrolyte to another. So this is the flow of electron. Electron flows from the anode side to the cathode side. So this setup is what we call a simple electrochemical cell, where oxidation reduction reaction takes place. That is where redox reaction takes place. Under this topic, we'll also be discussing electrochemical corrosion. Electrochemical corrosion. Corrosion can be defined as the deterioration of materials by chemical processes. That means that metals, when metals deteriorate through chemical processes, this is what we call corrosion. In other words, corrosion can be viewed as the spontaneous return of metals into their ores. The return of metal into their ores is what we call corrosion. The special characteristics of most corrosion process is that the oxidation and reduction steps occur at separate locations of the metal. On that same metal, oxidation and reduction step, they operate at different locations. It might be the same metal, but at different location on the metal. So how can we control corrosion? Corrosion can be controlled by what we call sacrificial coatings. That is the application of a coating of a more active metal. That is the particular metal that we want to protect from corrosion. How we can prevent corrosion from happening is by application of a more active metal on this particular metal. So that is what we call galvanizing. That process is what we call galvanizing. We can also prevent corrosion from happening by going through the process of cathodic protection. Cathodic protection, that is the maintaining of a continual negative electric charge on a metal. So that this dissolution as a positive ions is prevented. So we have come to the end of the topics under CHM 101 General Chemistry. See you some other time. Thank you.